You know what's interesting is we use MATLAB in the 390 programming class, but there's no formal instruction on how to use it.
Okay.
All the informal instructions on the VBA.
Oh.
They're like, oh yeah, do it on
I
MATLAB.
don't know why they even teach it anymore. No one uses that. Okay. Okay, so let's get started over here. Okay, we're going to start off with MATLAB. This is a student license version. Okay. Okay. And of course, like I said, you could either get it through Citrix and access it at home, but I was told that there's a limited number of licenses that CSUN has, and chances are that if you use it in a busy period, you might get on. So, what to do? You can either buy it, okay, yes?
This is the MATLAB.
Yeah.
Can you show me how you log into it? Because I didn't know how to log in.
Now you have to ask someone else after class, I can't because that, okay? Everyone here knows that. You know, just ask someone, okay? Okay.
Where's everyone?
Okay. So, what happens is that, it wasn't a current thought. Okay, so either you can get it, like I said, you know, through the Citrix, or purchase it, and I think a student license is, you get it for free, you know, almost for free, and then someone told me, you can actually get it for free. You go to the MathWorks website, and you get a trial version, it's for 30 days, and I guess what happens after that, you just do it again. They don't keep track, that's amazing. Okay, so that's what some people do, okay? But I recommend getting it because it's, you know, you're never gonna get it so cheap as when you're a student, and it's something that you'll use throughout your career, and certainly throughout, you know, the courses that you take here at CSUN. Okay. Now, I have to tell you that different versions have different interfaces over here, okay? I don't know what version I have here. I guess I could find out. Was it $sign version or something, a version?
It says 2015 at the top.
Okay, so it's right up there, okay. You may have an older version, a new version, but basically it's the same, okay? What will change is some kind of this front interface that you see, you know, these menus and stuff. But the commands, obviously, are, you know, always going to be the same. And what happens, you'll see right now there's this flashing prompt, okay? That means MATLAB is ready for input. Now, first we're going to basically use MATLAB as almost like an interactive calculator, okay? What makes it really useful, though, is that you can write and store very long programs, okay? And I'm going to illustrate that, too. How do you write a program? What's the difference between a program and a script, okay? This is MATLAB nomenclature, which we'll get to. Okay, let me do something very simple over here, okay? I'm going to do 3 plus 4, okay? Should be 7, right? Now you notice basically that it has ANS, okay, is 7, okay? And if I actually did ANS, it would be 7, okay? Most of the times you want to assign that to a variable, okay? But if you just make some type of, enter some type of command or a calculation and you don't assign it to anything, it'll give this temporary thing, you know, ANS. But what you really want to do is do something like, say, x equals 3 plus 4, okay? And I'll do this, x equals 3 plus 4, okay? Now, what happens is that if I just do it like that, it'll come back x is equal to 7, okay? Many times, especially when you're running a very long program, you don't want to see all the intermediate calculations. All you want to see is the net result from that MATLAB. So what you would do is that MATLAB has a syntax that if you terminate a line, command line, with a semicolon, it does the calculation, stores it, but doesn't show it to you explicitly. So I'll do, say, x equals 3 times 8. Sorry, 3 times 8, okay? And I'm going to put a semicolon. When you hit the return, okay, it's evaluated that, okay? Because if I do x now, I'll get 24, okay? Now, one thing which is very useful is that, you know, you're, say, running a program or whatever, and you have a lot of variables. This is what's called the workspace, okay? And what happens is a very good command, useful command rather, called whos, okay? Now, so far, what do we have in whos? We have ANS, which we did earlier, which is a 1 by 1, okay? And it tells you how many bytes it is. So x is a 1 by 1, okay? So these are all the variables that are in your workspace right now, okay? So if you lose track, if you do whos, you'll get the list of the variables together with their size, okay? Now, one of the things that you want to do, especially for plotting, is create vectors, okay? Now, in linear algebra, you recall, there's a distinction between a row vector and a column vector. And MATLAB adheres to that, and it's very strict. So let's enter a row vector, 1, 2, 3, 4, 5. So it'll be a 1 by 5. So the way that's done is you do x equals, okay? And then you put a bracket. That's how an array is signified in MATLAB. And now we'll just put the numbers in sequence, say 1, 2, 3, 4, 5. Okay? Notice basically that it did it as a row vector. Okay? And if we do a who's now, okay, let's see what we get. You see X, and you see the size is 1 by 5, 1 row, 5 columns. That's different than a 5 by 1. Okay? And of course you got, since each scalar is 8 bytes, it's a total of 40 bytes, okay, that you have there, reserved for X. Okay. Now suppose I want to write a vector as a column vector. Okay? I have two choices. I can enter it as a row vector like I did for X, okay? And this operation in linear algebra called transpose. What a matrix transpose does in general, it interchanges rows and columns. Well, if X is just a row vector, and I interchange rows and columns, what's X transpose? It's a column vector, okay? So if I do X transpose is just a apostrophe, you'll see the same vector but as a column. See? 1, 2, 3, 4, 5. I can also enter a vector as a column explicitly. And the way that's done, you say y equals like this. Now clearly if I did 1, 2, 3, 4, 5, separating them all by commas, that's a row vector. So MATLAB has a notation when you want to go to another row of a semicolon. So it does 1, semicolon 2, semicolon 3, semicolon 4, semicolon 5. That's equivalent, see, to 1, 2, 3, 4, 5. This will be useful when we enter matrices, which are two-dimensional arrays. We need rows and columns. Okay? One thing which I want to tell you is that one thing I want to tell you is that MATLAB is case sensitive. Okay? So remember we had X, which was 1, 2, 3, 4, 5. If I do big X, see, undefined. Okay? So there's a distinction between, so that's nice. So you can, you know, it's case sensitive. Okay? So that's a good feature. Okay. I want to say something called clear also. Suppose that you're doing something, you're all confused, you just want to start all over again. Okay. Rather than just shut off MATLAB and restart it, you do the following. Let's look at our who's again. So see who's there. Okay. So we got an X and a Y and A and S. If I do just clear by itself, it clears the entire workspace. Okay. If I wanted to clear just a single variable, suppose I just want to clear Y. I do clear space Y, okay? Now when I do a who's, you'll see that everything is there except Y, okay? Now we want to clear everything, just do clear, okay? And who's, of course, is now empty, right? Just we cleared everything. Okay. Let's do now vectors and matrices, okay? We already saw how to enter a vector explicitly. I did that 1, 2, 3, 4, 5. Many times you're entering a vector where, say the increment is 1 or something else fixed. And who wants to do, like 1, 2, 3, 4, 5, like that, okay? So suppose I want to have a vector u, and I want it to go from 0 to 8, okay? Steps of 1. So u equals, the left bracket again, I don't have to do 0, comma, 1, comma, 2, comma. I can do 0, colon, 8. The colon thing in MATLAB is used to designate like a range. So this says that the vector u starts off at 0, terminates at 8, and what's the step? The default is 1. Okay?
Well, it's same as in Excel. Same as in
Yeah,
Excel.
yeah, okay. And suppose I want a vector v to be 0 to 8, but I want to increment it by 2. Well, the syntax is v equals 0, okay? Now you put your increment, which is 2, and then finally the terminal value. Some languages, unfortunately, have that thing in a different order. You put your starting, your terminating, and your step. Here you put your initial value, your step, and 8. So this should give us 0, 2, 4, 6, 8. Okay? So, again, all this is in the documentation. One of the things which I think is fantastic about MATLAB compared to many other languages that I've used is that I think the documentation is excellent. Okay? For every command, they'll give you some very simple, start off simple, giving you sample problems, which I'll show you, and then it's very sophisticated program, so there's a lot of options. Many times you don't need all these bells and whistles, okay? Just give me the simplest use of it, and then if you go further into the documentation, you can explore each and every of the options that they have, okay? Sometimes you need this, sometimes you don't. So best thing is just use the simplest form first. If it works, why bother with the other stuff? Okay? Now what you can do also is extract elements of a vector. Notice how we had vector v, we said 0 to 8 steps of 2. Suppose for some computation I want to extract a third element of v. Okay? Kind of v of 3, will that do it? Yeah, it's 4. So therefore if you put a vector and you put in parentheses an integer, which is the element, it'll just extract that element. Similarly, I can extract a sequence of elements from v. Okay, v is still there, 0, 2, 4, 6, 8. Suppose I want to get the first 3 elements of v. Okay, not just a single one. I'll get the 0, the 2, and the 4. So I go v of, here comes that notation again with the colon. Element 1 through element 3. So I should get 0, 2, 4. Okay? Says colon notation is something which is going to be used over and over again. It indicates a range in MATLAB. Okay, let's go on out to matrices. Okay, what I want to do now is create a matrix that's, matrices in MATLAB can be complex, they can be real. Let's stick with real. They can be any size. The number of rows and columns don't have to be the same. Let's start off with a simple matrix that's a 3 by 3, where the first row is 1, 2, 3, second row is 4, 5, 6, and the last row is 7, 8, 9. How do you do a matrix? Okay, I'll make big A, because usually matrices are capital letters. Well, we start off with the first row, just like it was a vector. 1, 2, 3. Now I have to tell MATLAB to go to another row. If I continue with the commas, it's going to make it into a big row vector, right? So how do we do that? The semicolon now. Okay, then I do 4, 5, 6. Okay, go to the next row, semicolon, 7, 8, 9. And that's it. Okay. If we do a whos, let's see what it says about A. It says A is a 3 by 3 array, and that's 9 elements, obviously 72 bytes. Okay. And you can actually, once something is in the workspace, of course, you can just use it freely and operate on it. Okay. Suppose now, here's the matrix A over there. Suppose I want to extract the element in the second row, third column. I want to get that 6. So, as you could probably guess, A of 2, 3. You need 2 indices, right? First one for the row, second one for the column. And A23 should be a 6. Okay? Good. Okay. Now, let's do the following. Let's take parts of matrices. Okay? Suppose I want to extract the second column of A. Okay, I have to put A up there again. Okay? Many times you want to take a matrix and either extract a row or a column. Suppose I want to extract the A from the A matrix, the 2, 5, 8, that column. So I do A of, now we know the first index is row, right? Now I could put 1 through 3, but there's an easier way. You do this colon notation. So when it says A of colon something, it says you want every row in the matrix, and now just put the column that you want. We said we wanted column 2, right? So I should come up with the column vector 2, 5, 8. Okay? And similarly, suppose I wanted the last row of the matrix A, the 7, 8, 9. I do A of, okay, now the row number, I don't want all rows, so I'll put 3 for the row, and then for the columns, I want all columns. So I just put a colon. 7, 8, 9. Okay. Here's another thing that we can do. You can take partitions of matrices, okay? This is useful in structural mechanics, where you have Nastran models and you want to combine them or take parts of it. Here's the A matrix. Suppose I want to just get out the upper 2 by 2 block. I want to get the 1, 2, 4, 5. And I put a rectangle around that. Okay? Well, now you just have to give the range, okay, what you want. Now we have to be explicit. So I want A of, what rows do I want? I can't put a colon because I don't want all rows. I just want the first 2 rows of A. So I put row 1 to row 2. Okay? And now I want column 1 to column 2. So 1, 2. And you see how I got that upper partition from the first 2 rows, first 2 columns. Okay. Let's see what this is about. Okay. Let's create another matrix. So A is this, 3 by 3? Let me show you do matrix addition. This would create another matrix B, which is, I'm just going to do something. 4, 7, 8 for the first row, 1, minus 5, 4. I'm just doing things arbitrarily over here, semicolon, and then the last row, 6, 1, 0. Let's see, B should be a 3 by 3. Okay, B is a 3 by 3. So you see the A and the B over there, okay? And in linear algebra, you can add matrices provided they're the same size, same rows and same columns. So we have the addition of two 3 by 3s, and matrix addition in MATLAB means just, like in mathematics, means just add corresponding elements. So if you do A plus B, in the 1, 1 slot, I should get a 5, right? And in the 3, 3 slot, I should get a 9, and etc. So let's just do A plus B. And you see it did add the two matrices, okay? If you try to add matrices of different size, MATLAB will give you an error message. The error messages in MATLAB are very good, unlike many languages which just give you garbage. You know, if it encounters an operation that's not valid, it will stop and give you an error message. Let me just illustrate that. Do I have A here? Do I have X still? No. What do I have in blues? Let me just. I got U here, right? Okay. Clearly, I can't do A plus U, right? Doesn't make sense, right? A is a 3 by 3 and U is a 1 by 9. So let's see what MATLAB does. Matrix dimensions must agree. Okay? Very good diagnostics. Okay? Similar, I could do A minus B. You know, check this. Okay? It just takes A minus B. Oh, one thing which I want to show you is a convention which is actually used in, it's a MATLAB convention. Be very careful. Remember I just said that in mathematics, if you have a 3 by 3 matrix A, strictly speaking, if I say A plus 2, it makes no sense, right? I can't add a scalar 2, which is a 1 by 1, to a 3 by 3. But many times, okay, what you want to do, and this better be your intention, is that you like to add the same scalar to every element of a matrix, okay? That operation happens so often that MATLAB kind of violates the rules of mathematics and does that. So it's not going to object when I do A plus 2. What will it do? It'll take every element of the matrix A and add 2 to it. So I'll get in the first row 3, 4, 5, last row 9, 10, 11. Okay? So this is basically a violation of